Gooseneck Service Heads, while code compliant according to Section 250.54b of the National Electrical Code, are observed primarily in agricultural settings like farms and ranches. Their prevalence is notably less compared to alternative service head designs, yet they offer distinct advantages that cater to specific operational needs. These advantages primarily revolve around their utility in supplying electrical power to a diverse range of equipment typically found in such environments. Firstly, they are often employed to facilitate the connection of generators. In rural locations where grid power may be unreliable or during emergency situations, generators serve as a crucial backup power source. Gooseneck Service Heads provide a convenient and robust method for integrating these generators into the electrical system, ensuring a seamless transition to backup power when required. Secondly, pumps constitute another significant application. Farms and ranches frequently rely on pumps for irrigation, water distribution, and various other fluid transfer processes. Gooseneck Service Heads offer a secure and weatherproof connection point for powering these pumps, contributing to the overall reliability of the water supply system. Thirdly, compressors, essential for powering pneumatic tools, inflating tires, and operating various machinery, also benefit from the reliable power source provided by Gooseneck Service Heads. The design allows for a direct and stable connection, minimizing the risk of power interruptions that could disrupt operations. Beyond their functional benefits, Gooseneck Service Heads are also recognized for their relative ease of installation and maintenance. Their straightforward design simplifies the installation process, reducing the time and labor required for setup. Furthermore, their robust construction minimizes the need for frequent maintenance, translating into lower operational costs over the long term. However, it's important to acknowledge the potential drawbacks associated with Gooseneck Service Heads. Their aesthetic appearance is often cited as a concern, as their utilitarian design may not blend seamlessly with the surrounding environment. This can be particularly relevant in residential or commercial settings where aesthetics are a priority. As a result, their application is generally more confined to industrial and agricultural environments where functionality outweighs visual appeal. The construction also uses a metallic conduit formed into upside-down U or gooseneck shape. It is installed on the exterior of a building or structure, typically connecting to an overhead service drop. Conductors from the service drop enter the gooseneck and transition to the service entrance conductors, which then pass through the wall and connect to the service disconnect. The height of the gooseneck must comply with NEC requirements to provide adequate clearance from ground level and other structures. The materials used in constructing a gooseneck service head must be suitable for outdoor use and resistant to corrosion. This typically includes galvanized steel or aluminum conduit. The connections must be weatherproof to prevent moisture from entering the electrical system. Proper grounding and bonding are essential for safety. The gooseneck must be properly grounded to the building's grounding system to minimize the risk of electric shock. Local codes and regulations may have specific requirements for the installation of gooseneck service heads, including permits and inspections. The size of the conductors used in the gooseneck service head must be appropriate for the load they will be carrying. This is determined by the ampacity of the conductors, which is based on their size and insulation type. NEC Table 310.15 details ampacity. Overcurrent protection is crucial to prevent damage to the conductors and equipment in the event of a fault. Circuit breakers or fuses must be installed in the service disconnect to provide adequate protection. Weather heads are another common type of service head. They are designed to prevent water from entering the electrical system. They are typically used in areas where there is a high risk of rain or snow. Underground service entrances provide a more aesthetically pleasing option. However, they can be more expensive to install and maintain. Conduit is typically used to protect the conductors from physical damage. The type of conduit used depends on the application and local codes. Conductors are the wires that carry electricity. The size and type of conductors used must be appropriate for the load they will be carrying. Connectors are used to join conductors together. They must be properly installed to ensure a safe and reliable connection. Grounding electrodes are used to connect the electrical system to the earth. This provides a path for fault current to flow, which helps to protect people from electric shock. Bonding is used to connect metal parts of the electrical system together. This helps to equalize the voltage between different parts of the system, which reduces the risk of electric shock. Enclosures are used to protect electrical equipment from the environment. They must be weatherproof and properly grounded. Disconnects are used to shut off power to the electrical system. They must be readily accessible and clearly labeled. Overcurrent protection devices protect the electrical system from overloads and short circuits. They must be properly sized and installed. The National Electrical Code provides detailed requirements for the installation of electrical systems. It is important to follow the NEC and local codes to ensure safe and reliable installation. Electrical inspections are performed to ensure that electrical installations comply with the NEC and local codes. It is important to have electrical work inspected to ensure that it is done properly. Licensed electricians are qualified to install and maintain electrical systems. It is important to hire a licensed electrician to perform electrical work. Electrical safety is important to protect people from electric shock. It is important to follow safe electrical practices. Always turn off power before working on electrical equipment. Use insulated tools when working on electrical equipment. Never touch bare wires. If you are not qualified to work on electrical equipment, hire a licensed electrician. NEC Section 230 covers service entrances. This section outlines the requirements for service conductors, service equipment, and service disconnecting means. It includes requirements for the size and type of conductors, the location of the service disconnect, and the grounding and bonding of the service entrance. NEC Section 250 covers grounding and bonding. This section outlines the requirements for grounding and bonding electrical systems. It includes requirements for grounding electrodes, grounding conductors, and bonding jumpers. NEC Section 300 covers wiring methods. This section outlines the requirements for wiring methods such as conduit, cable, and wiring raceways. It includes requirements for the type of wiring method to use in different locations, the size of the conductors, and the support of the wiring method. NEC Section 310 covers conductors for general wiring. This section provides information on the allowable ampacities of conductors. It includes tables that list the ampacities of different sizes and types of conductors. NEC Section 408 covers switchboards and panel boards. This section outlines the requirements for switchboards and panel boards. It includes requirements for the size and type of conductors, the overcurrent protection, and the grounding and bonding of the switchboard or panel board. When selecting a service head, consider the following factors. Firstly, the size of the conductors that will be used. The service head must be large enough to accommodate the conductors. Secondly, the type of environment in which the service head will be installed. The service head must be suitable for the environment, such as wet or corrosive environments. Thirdly, the local codes and regulations. The service head must comply with all applicable codes and regulations. When installing a service head, follow these safety precautions. Firstly, disconnect the power before working on any electrical equipment. Secondly, use insulated tools. Thirdly, wear safety glasses. Fourthly, follow all applicable codes and regulations. The size of the service entrance conductors is determined by the total load of the building. The load is calculated by adding up the power consumption of all the electrical devices in the building. Service entrance conductors must be large enough to carry the total load without overheating. The overcurrent protection device must be sized to protect the service entrance conductors. The overcurrent protection device should be sized at no more than 125% of the ampacity of the service entrance conductors. The grounding electrode system must be properly installed to provide a path for fault current flow. The grounding electrode system typically consists of a ground rod or a ground plate that is buried in the earth. The grounding electrode system must be connected to the service entrance equipment with a grounding conductor. The bonding jumpers must be properly installed to bond all metal parts of the electrical system together. The bonding jumpers must be sized according to the NEC. The electrical system should be inspected by a qualified electrical inspector to ensure that it is installed correctly and safely. Electrical permits may be required for electrical work. Check with the local building department to determine if a permit is required. A licensed electrician is qualified to install and maintain electrical systems. It is important to hire a licensed electrician to perform electrical work. Electrical safety is important to protect people from electric shock. Follow safe electrical practices. This ensures a safe and reliable electrical system. Additionally, consider voltage drop, future load growth, and expansion requirements. It is also important to check for any specific requirements from the utility company. When making connections, ensure they are tight and properly insulated. Periodically inspect the service head and connections for any signs of damage or corrosion. Address any issues promptly to maintain safety and reliability. In summary, Gooseneck Service Heads are a code-compliant option, particularly useful in agricultural settings for powering diverse equipment. While less aesthetically pleasing than some alternatives, their ease of installation and maintenance, along with their functionality, make them a viable choice when appearance is not the primary concern.